All right, last video of the day from Trailer Studios. So another FRQ review problem, 2017, problem number 5. Okay, here we go. Two particles move along the x-axis between time 0 and 8. The position, so that's position of particle P, is given by this. So they're giving us the equation of the position as a function of time. Velocity of particle Q is given by this. All right, so they gave me the position function for P, the velocity function for Q. So particle Q is at position 5 at time equals 0. So that's telling me, so x of Q, 0 equals 5. Okay, so the initial condition for the position of Q is 5. So that's the preliminaries, that's what's up. Okay. All right, A. When is P moving to the left? Okay, so you got to ask yourself, what the heck? What are they looking for? Okay, that's when V of P, which equals xp prime, when it's less than 0. Okay, so A down here. Okay, P is moving to the left, kind of like a line dance. Okay, P is moving to the left when x prime P of t is less than 0. So guys, it's just a cute way of asking you to take the derivative. Okay, so I'm going to take the derivative of that thing. Okay, so x prime, the derivative of P, so it's a natural log. So the derivative of the natural log, it's actually the chain rule, guys. If you really want to think of it, it's the chain rule where chain rule, sorry. Yeah, it is chain rule. U equals t squared minus 2t plus 10. But you might just remember off the top of your head, we take the derivative of the natural log, it's 1 over the argument. It's 1 over the argument times the derivative of the argument. The derivative of this is 2t minus 2. Okay? So I need to find out where that is less than 0. So I'm going to start looking at the denominator. T squared minus 2t plus 10. I want to find out where's that negative, where that's positive. If you look at it, t squared minus 2t plus 10. So it starts when time is 0, it starts at a positive 10. At time 1, this is 1 squared is 1, minus 2. I'm still positive. In fact, say that this term is just going to make me more and more positive. This term is going to make me more and more negative. So it's like a race. If that term never existed, this thing would go to 0 when time equals 5. But if time equals 5, this is a lot more positive, and that's negative. Long story short, t squared minus 2t plus 10 is greater than 0 for all t. That never goes negative. All right? You could factor with the quadratic formula and show that as well, or you could just use that logic. But in the solution, they were just kind of just looking for that. So now what you got to look for is when is 2t minus 2 less than 0? Well, 2t minus 1 less than 0. So guys, that is less than 0. So x t is less than 0 when 0 is less than or equal to t is less than or equal to 1. That is the answer to problem number 1. That's when it's moving to the left. So xp t is going left, or you can say p is going left. Okay, so that's part A. Look at the solution. They give you 2 points for that. All right. B. Okay. So between this time, find all the times that the two particles are traveling in the same direction. Okay? So I'm going to need a table. Xp of t. So x prime p of t. And vq of t. Okay? So I know that there's xp of t changes sign at t equals 1. So I'm kind of coming up, I'm going to call them like kind of critical like numbers. Critical like numbers. I got 1 at x equals 1. Okay, so VQ equals t squared minus 8t plus 15. That equals t, let's see, minus 5, t minus 3. Okay, so this has critical numbers at, guys, that should have been t there, t equals 1. This has critical numbers when t equals 3 and 5. So I'm going to make my little table here. So I'm going to have, and guys, this should be t. These should all be t's. Okay, so I got t's less than 1, t's between 1 and 3. Oops, what's my less than sign there? T's between 3 and 5, and t is greater than 5. Okay, so x prime of t, we already showed in the first part, that's negative. When you're less than 1, it's positive otherwise. This VQ of t, okay, if I am less than, from less than 1, this is negative, negative times a negative is positive. If I'm less than 3 even, this is negative, I'm positive, okay? So if I'm between 3 and 5, this is positive, this is negative, that's negative. And if I'm greater than 5, that's positive. So where are they moving in the same direction? Where are the velocities have the same sign? So their velocities have the same sign. So velocities have the same sign here and here. So they are moving in the same direction at times 1 less than or equal to t less than or equal to 3, and 5 is less than or equal to t is less than or equal to 8, since their velocities have the same sign then. Okay, so that's the answer to part B. They give you 2 points for that. They give you 1 point to find the intervals, and 1 part to talk about the fact that they both have to have the same sign. So guys, I'll finish the second part of the problem C and D on the next video.